Today we're going to look at something that, well, I'm assuming you well and truly know. I hope you do at least. But I'm going to bring it back to scratch. Some teachers sometimes show you where it comes from, some don't, but how we derive the sine rule, why does it work? So that's just obviously any general triangle where we've labelled the vertices A, B, C, and so using common notation, the opposite side being the small letters A, B and C. Now at this stage we're assuming all we know is right angled triangle trig. So let's create a couple of right angled triangles. I'll just drop the perpendicular height in and conveniently call it H for height. I know, very creative of me. Now I can look at one of those triangles and say, well, H over C would be the sine of B. So that's looking at the left-hand triangle. But I could look at the right-hand triangle and say, well, hang on, H over B is equal to the sine of C. If I make H the subject in both of them, they're both equal to H, so therefore C sine B must equal B sine C. Rearranging that, getting to something more used to seeing, C over sine C is equal to B over sine B. Now, because I just chose those two sides, I could have easily done it with the other side, so the full one goes A over sine A equals B over sine B equals C over sine C. Well, I say it's the full one, but that, of course, is not the full sine rule. There's one thing missing there. Just do a quick example of using it. We could either use it to find a side, so in this case I'll use it to find H. So H over sine H is Q over sine Q. Rearrange, substitute in, then rearrange, and it's just calculator work from there really. And there it is, 45.8 units to one decimal place. Or of course we could use it to find an angle. And in that case we usually turn it upside down. You usually put what you're trying to find on the top of the fraction. So I'll go sine y over y is sine z over z. Substitute in, rearrange, and we get our answer of 46 degrees 58. And I'm quite confident that is the answer for this particular one. But of course we always should check with the sine rule, does our answer make sense? Now as I say in that last one, yes, it does make sense. But it doesn't always, because the thing about sine, it won't find obtuse angle, or your calculator won't find obtuse angles. Now I know in this one it can't be an obtuse angle because I've already got one in that triangle. You can't have two obtuse angles in one triangle, so that one's fine. But there's the sort of things we need to check. So have a look at things like the angle sum of the triangle. If I have this being obtuse, will it set my angle sum too big? But the other thing to keep in mind is the basic sine rule, the ratio bit. It means that the largest angle will always be opposite the largest side, the smallest angle will always be opposite the smallest side, and then obviously the middle size one will be opposite the middle size one. So that's something else you can use as a check. By the way, here it is. Circumcircle. See, if you'd looked on the next page, you could have said the answer. There's our full. A over sine A is B over sine B, C over sine C, the diameter of the circumcircle. Throw in the area of a triangle while we're at it. I mean, not all triangles do we have the perpendicular height. Yes, we know it's half base times height. So again, let's drop in the perpendicular height, but do it a different way. So the area we know is half base times height. Well, that's fine. We don't have a problem there. But remember, H over B is the sine of C. So H could be written as B sine C. So if I sub that in, I get a nice, neat little formula where I don't need the perpendicular height. Of course, it relies me of knowing two sides and the included angle. But as long as I've got that, I can find the area of the triangle. So in any triangle, depends which one you pick, but two sides and the included angle. So half AB sine C, half BC sine A, half AC sine B, whatever, go for your life on that. So a quick example, there we go. Oh, half DM sine F for this one. Subbing in, Look at that lovely answer. 25.47. By the way, I don't know if you've been taking note of how I'm writing my answers here. And I'm not just randomly picking, like I've gone to 2 decimal places in this one, and I think in the previous ones I went to 1 decimal place. If they don't tell me, I usually match. So if they're doing it to so many decimal places or significant figures, I'll match it. 4H we shall play with today. Enjoy.